The cheapest off-grid septic system is not the one with the smallest tank, the shallowest trench, or the friend who owns a backhoe. The cheapest system is the one your soil will accept, your county will permit, and your future self will not have to dig up in 3 years. That matters because septic has a brutal cost curve. A simple gravity system can be the affordable version: tank, pipe, distribution box, drain field, soil. But one wrong assumption can push you into pumps, dosing tanks, mound systems, engineered plans, or a failed drain field. That is how a cheap waste system becomes the most expensive hole on the property. So the first rule is uncomfortable. Do not start by digging. Start by proving the site. You need to know where the house sits, where the well sits, where water flows after rain, where the soil drains, where the truck can reach, and where the legal setbacks leave enough usable drain field area. If that first page is wrong, every dollar after it is gambling. In this field school build, cheap means gravity first, short pipe runs, correct slope, a tank sized by code, trenches sized by soil, and 0 hero moves with sewage. The target is not a secret illegal system. The target is a boring legal system that uses the ground properly and avoids paying for complexity you did not need. A basic off-grid septic system is a 2-stage treatment path. Stage 1 is the tank. Stage 2 is the soil absorption area, usually called the drain field or leach field. Wastewater leaves the house through one main building sewer. If the site is designed well, that pipe slopes downhill into the septic tank by gravity. Inside the tank, the water slows down. Heavy solids settle as sludge. Fats, oils, soap, and floating material form a scum layer. The clearer middle liquid, called effluent, leaves through an outlet baffle or filter. That liquid is not clean drinking water. It is only separated enough that the drain field has a chance to finish the job. From the tank, effluent moves to a distribution box or manifold, then into perforated pipes laid in trenches or chambers. The field spreads the water over a large soil area instead of dumping it in one wet pit. The soil does the real treatment. It filters particles, hosts microbes, slows pathogens, and protects groundwater when the site is suitable. That is the cheap system advantage. No pump, no controller, no aerator, no electric dependency. The system runs because water flows downhill and the soil breathes. The same simplicity is also the risk. If the soil is wrong, too wet, too shallow, compacted, overloaded, or illegally close to a well or waterway, a cheap gravity design stops being cheap. The soil decides the budget. Before buying a tank, prove the site in this order. First, mark the house, driveway, property lines, streams, ponds, seasonal wet spots, steep slopes, and any existing utilities. The drain field needs clean space, not leftover space. If you place it where vehicles must drive, where roof water drains, or where future buildings will go, you are building a future failure. Second, call the local health department or on-site wastewater office before you move dirt. In most places, they control permits, soil evaluation, required setbacks, minimum tank size, approved materials, inspection steps, and whether a licensed installer or designer is required. Rules vary by county, not by what a video says. Third, get the soil checked. That may be a perk test, a soil profile, or both. The point is to learn how fast the soil accepts water and how much usable unsaturated soil sits above groundwater, bedrock, or restrictive layers. Fast sand can move water too quickly. Heavy clay can move it too slowly. A high water table can kill the design even if the topsoil looks perfect. The cheap move is paying for this test early. It tells you whether a conventional gravity system is possible. It also stops you from buying pipe, gravel, chambers, and a tank for a layout the inspector will reject. One early soil answer can save thousands. Once the site passes the basic screen, design for gravity. The pipe from house to tank usually needs steady fall, commonly around 1/8 to 1/4 inch per foot depending on pipe size and local code. Too flat lets solids settle. Too steep can let liquid outrun solids. The exact slope is a code and design item, but the field principle is simple: smooth, consistent, downhill. Keep the tank close enough to the house to reduce trenching, but not so close that setbacks, access, or structure loads become a problem. Leave room for a pump truck hose to reach the tank lids. Install risers to grade if they are allowed or required. A cheap system that must be excavated every time it is inspected is not actually cheap. Place the drain field downhill from the tank only if the soil area and setbacks work. Do not aim it at the lowest wet spot just because gravity points there. The wettest area is often the worst treatment area. A drain field needs oxygen in the soil. If the soil stays saturated, it cannot treat wastewater properly. Also plan a reserve area. Many jurisdictions require one. Even when they do not, you want a future replacement zone that stays untouched. Do not park on it, build on it, plant trees on it, or run heavy equipment over it during construction. Cheap septic is really land management. Protect the soil before it becomes the system. The tank is not where you save money by going undersized. A typical small home may use a 1,000 to 1,500 gallon septic tank, but the legal minimum depends on bedrooms, design flow, and local rules. Some codes use bedroom count because bedrooms predict future occupancy better than today's lifestyle. A couple living lightly in a 3-bedroom house may still need a 3-bedroom rated system. The real cheap decision is material and access. Concrete is common, durable, and heavy. Plastic and fiberglass can be easier to move on remote land, but need correct bedding, anti-float precautions where groundwater is high, and careful backfill. Used tanks are risky unless they are approved, undamaged, watertight, and legal in your area. A cracked bargain tank can contaminate soil and ruin the inspection. The tank needs inlet and outlet baffles, an effluent filter if required or recommended, watertight lids, and access for pumping. Put the filter where it can be cleaned without archaeology. Mark the tank location on a map before the grass grows back. For pipe, use approved sewer pipe, not random thin drain pipe. Use cleanouts where the layout needs them. Bed pipes so they do not sag. A belly in the line becomes a solids trap. Every cheap part has a job. If the part cannot survive burial, soil movement, cleaning, and inspection, it is not cheap. It is delayed rework. The drainfield is the expensive part to ruin. Build it only when the soil is dry enough to work without smearing or compacting. Heavy equipment on wet soil can seal the very pores that are supposed to absorb water. If the excavator leaves shiny, smeared trench walls in clay, treatment capacity drops before the first flush. The usual gravity field uses trenches, gravel and perforated pipe, or chamber units, depending on the approved design. The trench bottom must be level across each run, so one end does not take all the water. The distribution box must also sit level. If one outlet is lower, that trench overloads while the others stay underused. A cheap field is not one short trench. It is the correct absorption area for the soil and design flow. Soil with slower perk needs more area. More bedrooms usually mean more design flow. Local tables or the designer convert perk rate and flow into trench length, chamber count, or square footage. Do not guess with sewage. Sequence matters. Excavate to the approved depth. Keep loose soil and mud out of the trench. Set gravel or chambers per spec. Lay pipe level where required, with holes oriented as specified. Cover with approved fabric or barrier if the design calls for it, then backfill gently. Do not run heavy equipment over the finished field. The final grade should shed stormwater away, not funnel roof runoff onto the trenches. Use simple sizing math to understand the quote, not to override the permit. Start with design flow. A common homeowner mental model is bedrooms times roughly 120 to 150 gallons per day, depending on the state or guide. A 3-bedroom house may therefore be treated like 360 to 450 gallons per day, even if you personally use less. Tank size often gives about 2 days of detention at design flow, with minimum tank tables set by code. That is why a 3 or 4-bedroom home often lands around 1,000 to 1,500 gallons. The tank is not just a container. It needs enough quiet time for solids to separate before liquid reaches the field. The drain field is sized from design flow and soil acceptance. If the soil accepts water slowly, you need more trench area. If the soil is too shallow above groundwater, you may need a mound or advanced system. That is where the price jumps. For cost, think in tiers. A simple permitted gravity system on good soil may land in the several thousand to low 5-figure range depending on region, access, material, and excavation. A difficult engineered or mound system can be much higher. The cheap lever is not cutting the system smaller. The cheap lever is picking a good site, keeping gravity, shortening runs, scheduling excavation efficiently, and avoiding redesign after the inspector arrives. Install day should feel boring. First, confirm the approved plan is on site. Mark the tank, pipe route, drain field, setbacks, and reserve area. Confirm the weather. Do not open a drain field in saturated soil just because the machine is already rented. Second, dig the tank hole and pipe trench. The tank hole needs correct depth, stable bedding, and safe excavation practices. Trenches can collapse and septic tanks are confined space hazards. Nobody climbs into a tank. Nobody stands under an unstable wall. Cheap does not mean casual around heavy soil and wastewater infrastructure. Third, set the tank level. Check inlet and outlet elevations. Connect the building sewer to the tank with correct slope and fittings. Connect the outlet to the distribution box or field line. Keep debris out of every pipe. Test for obvious leaks or alignment problems before burying. Fourth, build the drain field exactly to the approved layout. Level the distribution box. Confirm equal outlet elevation. Install trenches, chambers, gravel, pipe, fabric, and backfill in the specified order. Photograph the open system before cover if allowed. Keep those photos with the permit and final map. Fifth, do the inspection before hiding anything that must be seen. This is where patient builders save money. Reopening a covered trench is expensive. Waiting for the inspector is annoying. Digging twice is worse. There are good ways to save money. Save by choosing land with usable soil before you buy or build. Save by placing the house so the waistline runs downhill and the drain field has room. Save by keeping roof runoff, driveway runoff, and livestock traffic away from the field. Save by getting quotes after the soil test, not before. Save by doing owner-allowed work around the system. Clearing brush, improving access, marking utilities, moving materials, installing erosion control, and documenting the layout. In some areas, owner installation is legal with inspections. In others, it is not. The rule is local. Do not assume. Save by avoiding unnecessary features. If gravity works, pumps add cost and future failure points. If a conventional field is approved, do not upgrade to a complicated system for vanity. If a small cabin has low legal design flow, size it correctly instead of copying a large suburban system. There are also places not to save. Do not skip the permit. Do not shrink the drain field. Do not use unapproved pipe. Do not bury a damaged tank. Do not ignore setbacks from wells and water. Do not let the excavator compact the field. Do not route gray water or roof water into the septic unless the design explicitly allows it. These shortcuts do not make the system cheap. They make the failure expensive. The first failure sign is water moving where it should not. Slow drains, gurgling toilets, sewage odor, wet ground over the field, unusually lush strips of grass, or effluent surfacing after laundry day all point to overload, blockage, or field failure. Do not wait until sewage backs into the house. The common install mistakes are predictable. The tank outlet is set wrong. The pipe has a belly. The field is too small. The distribution box is not level. The trenches are built in smeared wet soil. The field receives driveway runoff. A tree is planted over the line. Someone drives across the reserve area. The tank never gets pumped, so solids move into the drain field and clog the soil. The worst mistake is treating the tank like the expensive part and the field like cheap dirt. The field is the fragile asset. A tank can often be pumped, cleaned, repaired, or replaced. A sealed, compacted, biomat-choked drain field may need a new location. If the system fails early, diagnose in order. Household water use, leaking toilets, tank solids level, outlet filter, distribution box, field saturation, surface runoff, and soil compaction. Guessing leads to random repairs. Following the flow path tells you which part is failing. Septic rules exist because a bad system can contaminate wells, streams, groundwater, and the people living on the land. Off-grid does not mean outside public health. It usually means you are personally responsible for the waste treatment that a town sewer would normally handle. Check local rules for permits, license design, setbacks, tank size, drain field sizing, inspections, repair areas, gray water, composting toilets, and whether alternative systems are allowed. If the site has high groundwater, shallow rock, flooding, steep slope, small lot size, or nearby water, expect more requirements. Maintenance is the cheap insurance. The EPA homeowner guidance is to inspect a typical household system at least every 3 years and pump the tank generally every 3 to 5 years, depending on use, tank size, solids, and local advice. Alternative systems with pumps or mechanical parts need more frequent attention. Protect the field every day. Use water efficiently. Fix leaking toilets. Spread laundry across the week. Do not flush wipes, grease, chemicals, paint, solvents, or medications. Keep vehicles and structures off the field. Keep deep-rooted trees away. Keep drainage away. Clean the effluent filter if your tank has one. Keep records of pumping, inspections, repairs, and the final layout map. The cheapest septic system is maintained before it smells. Use this checklist before money leaves your pocket. 1. Confirm local permit rules and whether you need a licensed designer or installer. 2. Map house, property lines, water bodies, slopes, driveway, utilities, and reserve field. 3. Complete the required soil test or site evaluation. 4. Confirm a gravity system is actually possible. 5. Choose the house and tank positions to keep pipe runs short and downhill without violating setbacks. 6. Size the tank by code, usually based on bedrooms or design flow, not today's low-use fantasy. 7. Size the drain field by soil and design flow. 8. Choose approved tank, pipe, pipe, chambers, gravel, fabric, risers, and filter components. 9. Schedule excavation for dry workable soil. 10. Set the tank level on proper bedding. 11. Keep the building sewer slope consistent. 12. Level the distribution box. 13. Build trenches to the approved depth, length, and spacing. 14. Protect open trenches from mud, smearing, and compaction. 15. Inspect before cover. 16. Backfill gently and grade surface water away. 17. Mark the tank, cleanouts, distribution box, field, and reserve area on a map. 18. Install risers or access covers where allowed. 19. Keep heavy traffic off the field forever. 20. Inspect and pump on schedule. That is how you install off-grid septic cheap. Let gravity do the work, let soil decide the design, let the inspector see what matters, and never save $1,000 in a way that creates a $15,000 failure.